Till now we have studied about the unit vectors of spherical polar coordinates, that was r cap, theta cap and phi cap, and we have calculated the values of r cap, this, theta cap and phi cap. So now we will discuss the motion of a particle moving in a spherical polar coordinates. So since the particle is moving in spherical polar coordinates, let us suppose initially the point was at point P when the coordinates, spherical polar coordinates of that points were r, theta and phi. Now after some time, let us suppose the particle moves to the next position, that is P dash, and the coordinates according to that will change from r will change to r plus dr, means additional distance of dr has been moved by the particle. And as we have already discussed that theta and phi, they are also not constants, so phi will also change and theta will also change. So initially it was theta, now d theta angle has been added additionally. So now the coordinate for theta will be theta plus d theta, and for phi also the particle will move an angle from phi to phi plus d phi. So the new position will be P dash, that is having coordinates r plus dr, theta plus d theta and phi plus d phi. So discussing about the motion of the particle, the primemost thing we need to find is displacement. Displacement of a particle in spherical polar coordinates. We have already discussed about the motion of a particle, displacement, velocity and acceleration in Cartesian and plane polar coordinates. Now the displacement of a particle in spherical polar coordinate will consist of three components. First point will be the displacement of which coordinate? R, when your theta and phi were constant. So first is displacement due to R, second is displacement due to theta, third is displacement due to phi. So component of displacement due to increase in theta when your phi and r, they are constant, means two components are constant, your angle is, theta angle is only changing, so d theta is changing. It means this is displacement is linked to, if this is the angle d theta, that is total moved angle d theta, so displacement linked to it will be PA, or if you see this, you can view that CB is also same, EF is also same, BP dash is also same. It means since we are talking in a three-dimensional geometry, so if one side is, we are calculating all the opposite sides, like PA is equal to BC, so displacement will be PA, or that will be equal to BC, or it is equal to EF, or equal to DP dash. Now if I calculate the value of PA, so if I consider it as a small arc PA, then what will be the value of PA? PA will give me arc into radius, r d theta. Now what is changing? Theta is changing, so unit vector along this will be theta cap. Now this is my first component. What will be my second component? Second will be displacement due to change in phi when your r and theta, they are constants. So r and theta is constant, your phi is changing. See, this is your d phi and the side linked to this is PC or AB or FP dash or ED. So my displacement will be PC or AB or ED or FP dash, and you can clearly see that the PC is also equal to the displacement Mn, and we can easily calculate the value of this Mn from here, since angle is d phi, angle is changing. So this is also equal to Mn. And as we have previously discussed, when we discussed the relation between this spherical and Cartesian coordinates, we have already discussed the value of this Mn. What will be the value of Mn? Mn will be your rho sine, this will be your rho sine theta, this OM with d phi. So if I consider this as a small arc, this is rho sine theta d phi. So this will give me displacement due to change in phi. Now my third one is displacement due to change in r when your theta and phi, they both are constant. So since r is changing, it means this is the line, this is the displacement, that is BP dash. This is also equal to CD equal to AF or equal to PE. Now if I see, this is my r distance, this is also my r distance up to O to B, and BP dash, this is r plus dr, so this will be dr. So BP dash will be dr into its unit vector. Since unit vector along this is r cap, so I get this. Now I know that the total displacement is a sum of all these three displacements, but also I know that from this PAAB quadrilateral, BP dash and PP dash, I know that from vector laws, PP dash is equal to PA plus AB plus BP dash. Now I have all the values. I can put, what is my PA? PA is my R d theta, theta cap plus AB sine theta d phi plus my dr. Sine theta d phi. So displacement is my dr r cap, r d theta theta cap, r sine theta d phi. Initially we calculate with respect to rho and then we put the value of rho and we ultimately got r sine theta. So I have directly written r sine theta d phi. So this is my displacement. Now I can also calculate this value with direct from the vector, like I am having r vector is equal to r into r cap. If I differentiate both sides, r cap, what I will do? dr r cap plus r dr cap. Now this is my displacement. I don't have the value of dr cap, but I have the value of r cap, that is I cap sin theta cos phi plus j cap sin theta sin phi plus k cap cos theta. I can directly calculate the value by differentiating both sides. If I differentiate this side, I will get dr cap. If I differentiate this whole side, then what I will get is I cap sin theta, differentiation of sin theta, that is cos theta d theta cos phi plus differentiation of cos phi, that is minus I cap sin phi d phi into sin theta plus second term. Differentiate it. You will get j cap differentiation of sin theta, that is cos theta d theta sin phi plus j cap sin theta as such differentiation of sin phi, that is cos phi d phi minus k cap sin theta d theta. Now I will take the d theta term in the same bracket. This is I cap cos theta cos phi j cap cos theta sin phi minus k cap sin theta in one bracket and phi terms in another bracket plus d phi. This gives me I cap sin phi into plus j cap sin theta. I can take sin theta common over here. Sin theta is common here also, plus j cap cos phi d phi. So now this is the value for theta cap and this is the value for phi cap. So I get dr cap equal to d theta into theta cap plus sin theta d phi into phi cap. Now I put this value in this equation. This is my displacement equation. Let it be 1. So when I put the value, I will get displacement equal to dr into r cap plus r into, that is d theta theta cap plus sin theta d phi phi cap. So this is my dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. This is my displacement. This is what I wanted to find. Now I know that velocity is my rate of change of displacement. It means if I divide this equation throughout with dt, let it be 2, divide this equation by dt throughout. So I will get dr by dt, that will become my velocity v equal to dr by dt r cap plus r d theta by dt plus r sin theta d phi by dt phi cap. So I can write this is r dot r cap plus r theta dot theta cap plus r sin theta phi dot phi cap. This is my velocity. This is my Vr component, V theta component and V phi component, and I can write V is equal to Vr plus V theta plus V phi. So this is my total velocity of a particle moving in spherical polar coordinates. Now we move on to the acceleration part. So what will be the acceleration of a particle moving in a spherical polar coordinate? Now velocity is V is equal to r dot r cap plus r theta dot theta cap plus r phi dot sin theta into phi cap. Now we want to find the acceleration. We know that acceleration is dv by dt. Now if I differentiate these two this equation on both sides, what I will get is that is dv by dt, and I am directly applying the differentiation rule. First function as such, differentiation of first into second function as such, plus first function as such differentiation of second, plus r dot theta cap. By now all of you are aware about what is r dot. R dot is dr by dt and r double dot is d square r by dt square. So then move on to next, r theta double dot theta cap plus r theta dot d theta cap by dt plus r cap r dot phi dot sin theta phi cap plus r phi double dot sin theta phi cap plus r phi dot differentiation of sin theta, that is cos theta d theta by dt. It means additional theta dot will come here. So into phi cap plus r phi dot sin theta d phi cap by dt. So if I see, first term will give me 2 terms after differentiation, this will give me 3 terms after differentiation, and this will give me 4 terms after differentiation. Now these are understood, r double dot, r dot, r dot, theta dot. Now what is the challenge? Challenge is to find the value of dr cap by dt, to find the value of d theta cap by dt, and to find the value of d phi cap by dt. Now let us first see dr by dt. As we know that r cap, that is a function of theta and phi. Theta cap, that is a function of theta and phi. Phi cap, that is a function of only phi cap. Now how can I calculate the values of curly r cap or dt by dr cap by dt? Since r cap is a function of theta and phi, I can write it like this, by dt. Similarly, d theta cap by dt can be calculated as curly theta cap by curly theta into curly theta by curly t plus curly theta cap by curly phi into curly phi by curly t. But your phi cap, that is only a function of phi. So I can only differentiate it with respect to phi. I cannot write it as curly phi cap by curly theta, since this is a component of phi cap only. So let us first calculate curly r by curly t. To calculate dr cap by dt, I need to calculate the value of curly r cap by curly theta, curly r cap by curly phi, and then I will put these values and will get this value. Now from this equation, if I differentiate r cap with theta, what will I get? Since this is a partial differentiation, so I will get differentiation of sine theta, that is cos theta d theta by d theta, that is 1 into cos phi as such, plus j cap cos theta into sin phi minus k cap sin theta. Now if I clearly see this, what it is giving me? It is giving me the value of theta cap. So curly r cap by curly theta is basically my theta cap. Now if I differentiate this equation with respect to phi, what will I get? I will get I cap sin theta as such. What is my differentiation of cos phi? Minus sin phi d phi by d phi, that is 1, plus j cap sin theta sin phi. Differentiation of sin phi, that is cos phi d phi by d phi, and next differentiation is 0. So if I take sin theta common, it will give me minus I cap sin phi plus j cap cos phi. So this is sin theta. If you clearly see, this is my phi cap. Now I put the value over here. In this value, I will get dr cap by dt. Dr cap by dt is curly r by curly theta, that I calculated as theta cap, into curly theta by curly t, that is theta dot, plus phi dot into sin theta phi cap. So this give me curly r cap by curly t. Similarly, I can move on to theta cap. I can calculate the value of, so I'll keep this value with me. Dr cap by dt is theta cap, theta dot, phi dot, sin theta phi cap. Now similarly, I can find the value of curly theta by curly theta. If I differentiate this, I can get I cap minus sin theta cos phi plus j cap minus sin theta d theta by d theta, that is 1 into sin phi minus k cap cos of theta. So this is my, if I take the minus common, I will get I cap sin theta cos phi plus j cap sin theta sin phi plus k cap cos theta, and this is nothing else. This is my r cap. Now to calculate curly theta cap by curly phi. Curly theta cap by curly phi will give me I cap cos theta minus sin phi plus j cap cos theta cos phi. This is 0. So if I take cos theta common, minus I cap sin phi plus j cap cos phi. So this will give me cos theta into phi cap. Now I will get the value of curly theta cap by curly t. This will give me, put the value, I will get minus theta dot r cap, put the value over here, plus cos theta phi dot phi cap. So this is my second value. Now I will get the value of, for phi, I will only calculate with respect to phi and will get from here I cap cos phi minus j cap. Cos phi differentiation is sin phi into phi dot. Now I have all these three values, dr by dt, d theta by dt, d phi by dt. Now I will put all these three values in this equation. So my dv by dt will become r double dot r cap plus r dot, what is the value of dr cap by dt? This is theta dot theta cap phi dot sin theta phi cap plus r dot theta cap plus r theta double dot. This is bit lengthy. R theta dot. Now you will put the value of d theta by dt. That is your minus theta dot r cap plus cos theta phi dot phi cap plus r dot phi dot sin theta phi cap plus r phi dot sin theta phi cap r phi dot cos theta into phi cap r phi sin theta, that is minus I cap cos phi plus j cap sin phi into phi dot. Now what we need to do is, we just need to separate the components. Like if I acceleration, this is my acceleration. So acceleration is, we have number of terms, r cap, phi cap, theta cap. So what we need to do is, we just collect the terms in brackets and we will get the total value of acceleration. Like this acceleration will come out to be totally, it will be the component are, when we gather the components, as I told you, r cap in one bracket, theta cap in another bracket, and phi cap in third bracket, then we will get A is equal to AR into r cap, A theta into theta cap, and A phi into phi cap. So these are the components. This is AR component, A theta component, and A phi component. So this is my acceleration. So we have discussed about the motion of a particle, that is displacement, velocity and acceleration of a particle when it is moving in a spherical polar coordinates. So this is all about the motion of a particle. Thank you.